You can feel completely fine, rested, relieved, genuinely happy while your brain quietly begins the process of self-dismantling. Not metaphorically, not in some vague long-term statistical sense, measurably, structurally. Within months of leaving the workforce, one of the most critical memory regions in the human skull begins losing volume, and the more comfortable you feel during those first weeks of retirement, the more likely it is that the process is already underway. Here is what makes this particularly strange. The very thing protecting your brain right now, the thing you have been complaining about for years, maybe decades, is the pressure, the cognitive load of work, the problem solving, the deadlines, the social navigation, the adaptive thinking you do inside a high stakes environment every single day. Strip that away, and the brain does not rest. It economizes. It begins quietly shutting down circuits it no longer considers essential. And because the brain is extraordinarily good at this, you do not notice while it is happening. By the end of this, I am going to walk you through what the research shows happens to the brain from day one of retirement through the first 5 years, stage by stage, with the specific mechanisms behind each shift. And I am going to give you the triple load protocol. Three measurable daily inputs that the neuroscience suggests can interrupt this trajectory entirely. Not supplements, not crossword puzzles. Something the mainstream wellness conversation almost never touches because it cannot be sold in a subscription box. But to understand why the protocol works, you have to understand what retirement is actually doing and why the biology makes it so counterintuitive. The invisible villain in this story is not aging. It is not genetics. It is cognitive unloading, the gradual, invisible reduction of the mental challenge your brain has been exposed to every working day, often for 3 or 4 decades. Work was functioning as a gym for your brain without you realizing it. Retirement, for many people, is the day they cancel the membership, and the brain responds to that cancellation the same way any muscle responds when the load disappears. It begins to atrophy. Think of the brain's neural pathways as a power grid. Every time you solve a problem, manage a conflict, navigate an ambiguous situation, hold a deadline in working memory, or read a room and adjust your communication on the fly, you are sending electrical current through specific circuits in that grid. The circuits that carry regular traffic get reinforced. More insulation on the signal pathways, faster transmission speeds, greater capacity. The circuits that stop carrying traffic get flagged by the brain as inefficient. And the brain, which is the most energy-hungry organ in the body, consuming roughly 20% of your total caloric intake despite accounting for only about 2% of your body weight, is obsessively focused on efficiency. It shuts down underused circuits to conserve energy. This process is called synaptic pruning, and it is not a malfunction. It is the brain doing exactly what evolution designed it to do. The problem is that retirement triggers a sudden dramatic drop in cognitive load, and the pruning response that follows is far larger than the brain was designed to handle in a compressed window of time. That is the invisible villain. That is the mechanism. Now here is how it unfolds, stage by stage. The honeymoon circuit, day 1 through roughly week 2. The first thing that happens when you retire is not what you might expect from a health standpoint, which is to say, it genuinely feels wonderful. And that is precisely the problem. Cortisol, your primary stress hormone, the compound that kept you alert before hard meetings, woke you at 3 in the morning rehearsing tomorrow's presentation, and kept your sympathetic nervous system on low-level standby for most of your career, drops sharply. Heart rate variability improves. The autonomic nervous system, which governs the balance between stress arousal and recovery, becomes more regulated. Inflammatory blood markers that tend to rise under chronic occupational stress often decrease in these first 2 weeks. Sleep becomes deeper. You feel better than you have in years, and you should. Chronic occupational stress at high levels is genuinely damaging over long time horizons, and nobody should romanticize the burnout years or suggest that working until you collapse is health strategy. That is not what this is about. But here is what is happening simultaneously in a different part of the brain that the relief is masking. The prefrontal cortex, the region sitting directly behind your forehead, responsible for planning, working memory, impulse control, complex decision-making, and the management of competing priorities, begins reducing its daily activation load. For decades, that region was being exercised every single working day, often for 8, 10, or 12 hours. Now, within the first week of retirement, the demands on it drop to a fraction of their former level. The brain notices the change immediately. It does not sound an alarm. It begins redistributing resources. The power grid starts rerouting electricity away from circuits that are no longer being called upon. You experience this as relief. The brain is registering it as a significant environmental signal. The cortisol cliff, week 2 through month 1. Around week 2, something subtler begins that most retirement health conversations entirely miss. Cortisol, which was genuinely oppressive in its chronic form, was also doing something else alongside the stress. It was anchoring your biological clock. The circadian rhythm, your body's internal 24-hour timing system, is maintained by consistent external cues. Neuroscientists call these cues Zeitgebers, which is German for time givers. Light exposure is one, meal timing is another, but social contact, task demands, and structured time pressure are powerful Zeitgebers in their own right. The alarm clock, the commute, the 9 o'clock meeting, the midday transition, the late afternoon wind down, the 5 o'clock shutdown, these were all acting as daily anchor points for your circadian system week after week for decades. When those cues disappear simultaneously on the first day of retirement, the circadian rhythm loses its anchoring structure and begins to drift. Sleep timing shifts, often later, meal timing becomes irregular, and this matters for brain health in a very specific way, because the hippocampus, the seahorse-shaped structure deep in the temporal lobe, the region responsible for converting your daily experiences into lasting memories, is exquisitely sensitive to circadian disruption. The hippocampus performs most of its memory consolidation work during slow-wave sleep, which is the deepest stage of non-REM sleep. When circadian rhythm drifts, slow-wave sleep architecture degrades. And when slow-wave sleep quality drops, the hippocampus becomes substantially less efficient at its primary function. Many new retirees describe this period as a strange, mild flatness. Not depression, not illness, a slight fog. They misplace things more often than before. Word retrieval feels marginally slower. They are not imagining this. These are early hippocampal symptoms, and they are happening before any of the larger mechanisms have fully engaged. The identity erosion, month 1 through month 3. Here is the piece that most retirement planning conversations ignore entirely, because it is not about money and it is not about physical health in any obvious sense. It is about what neuroscientists and psychologists call identity architecture, the neural scaffolding around your self-concept. For most people who spent decades in meaningful careers, the answer to the question, "Who are you?" was partially, sometimes substantially, built on what you did professionally. This is not vanity or misplaced priorities. This is just how the brain encodes identity. Self-concept in the brain is maintained through narrative, through the ongoing stories you tell yourself about your competence, your relevance, your place in a social system that values your contribution. These narratives are actively reinforced every time someone calls you for advice, every time a problem lands on your desk, every time the existence of your role signals that you are needed. When retirement removes all of that simultaneously, the brain undergoes what researchers have described as role exit, a fundamental restructuring of self-concept that the brain processes at the neurological level with some of the same machinery it uses for grief. The anterior cingulate cortex and parts of the prefrontal cortex, regions that show elevated activation during bereavement, show similar activation patterns during significant role exit experiences. The brain is not being dramatic. It is responding to a genuine structural loss. The working self, which was a central organizing framework, is gone. This is where cognitive unloading and identity erosion compound each other in a way that is rarely discussed. When you are processing loss, the prefrontal cortex is already partially occupied with that processing load. When that same region is simultaneously losing its daily workout because the cognitive demands of work have vanished, You are placing two major stressors on the same neural real estate at the same moment in time. The brain handles this the only way it knows how. It deprioritizes maintenance on circuits that are not being actively used, and it increases the emotional salience of the lost signal, which is why so many retirees are surprised by how emotional and disorienting the first several months can feel, even when they genuinely wanted to retire. The Institute of Economic Affairs in the United Kingdom analyzed data from roughly 8,000 retired workers and found that full retirement increased the probability of clinical depression by 40% and the probability of being diagnosed with at least one physical health condition by 60%. Not among people who were already fragile or already struggling. Among the general retired population, these are not marginal numbers. And now here is the moment where I have to tell you that a significant part of what you have been told about protecting your brain after retirement is genuinely incomplete. We have been told for decades that the prescription for cognitive aging is to keep your mind active. Do crossword puzzles. Download a brain training app. Try learning a language on your phone for 15 minutes a day. And the research has increasingly and specifically shown that this advice, while not harmful, dramatically misses the point of what actually protects the brain. A 2014 analysis of trials involving cognitive training games, published in the Proceedings of the National Academy of Sciences and signed by more than 70 prominent neuroscientists and cognitive psychologists, raised formal concerns about the gap between the marketing claims of brain training products and what the actual controlled research demonstrated. Subsequent studies confirmed that cognitive training games evaluated against proper active control groups showed no meaningful reduction in dementia risk and no meaningful transfer to real-world cognitive function. The brain does not strengthen its prefrontal circuits by playing a matching game. It never did. Here is what actually works and why. The kind of cognitive load that protects the brain is not the kind delivered by a gentle app. It is the kind produced by high-stakes, socially embedded, emotionally significant challenges that simultaneously demand working memory, executive function, social judgment, and adaptive problem-solving. In other words, what work was, with all its frustrations included. The frustrations were not incidental, they were the mechanism. Dr. Yakov Stern at Columbia University developed the concept of cognitive reserve over decades of research. Cognitive reserve is the brain's resilience against damage, its ability to recruit alternative neural networks when primary pathways are disrupted. What Stern's work established, and what subsequent research has confirmed across multiple populations, is that cognitive reserve is not a fixed asset. It is not a savings account that holds its value in a vault after you stop contributing to it. It is more like a garden. Stop maintaining it actively, and it degrades regardless of how much you grew over the previous 40 years. That is the specific thing the crossword puzzle advice misses. It is not about keeping the brain occupied. It is about keeping the brain under meaningful, novel, social cognitive load. Those are three separate criteria, and all three matter. The grid goes dark, month 3 through month 6. By month 3, the power grid metaphor stops being a metaphor and starts being measurable physiology. Research using functional MRI, a brain imaging technique that tracks blood oxygen levels as a proxy for neural activity, showing in real time which regions are consuming the most energy, has demonstrated that adults who significantly reduce their cognitive engagement after retirement show measurable decreases in activation in the prefrontal cortex and anterior hippocampus during memory encoding tasks. The circuits are not damaged. They are simply running at lower power, less blood flow, less metabolic activity, less electrical traffic through the connections. When circuits go dim long enough, the brain makes a resource allocation decision. Synaptic pruning accelerates. Remember, this is the normal maintenance process by which the brain eliminates synaptic connections it has determined are redundant or underused. It is efficient. It is not a disease. But when a sudden retirement-related drop in cognitive load triggers it across multiple circuit systems simultaneously, the scale of pruning is far larger than the brain would experience under normal gradual conditions. Consider the evolutionary logic. The human brain evolved under conditions where reduced environmental demand was a signal of safety, and therefore a signal that energy conservation was appropriate. A hunter-gatherer who no longer needed to track animals, navigate terrain, and coordinate complex social strategies with a group would have the brain economize those faculties because maintaining peak capacity across all of them cost calories that were better conserved. Your brain cannot distinguish between I retired to a comfortable home with a pension and the survival demands of my environment have decreased significantly. It responds to the same signal, reduced load, reduce the budget for the circuits responsible for managing that load. What this looks like behaviorally between months 3 and 6 is what many retirees describe as a subtle but real change in mental sharpness. Word retrieval slows, the tip of the tongue phenomenon, where the right word is clearly somewhere in memory, but the pathway to retrieve it feels momentarily unavailable, becomes more frequent. This is the language network showing early signs of reduced pathway maintenance. The vocabulary is intact. The retrieval infrastructure is narrowing from disuse. Decision-making under even mild time pressure feels slightly more effortful. The ability to hold multiple competing pieces of information in mind simultaneously, called working memory capacity, begins declining faster than it would through biological aging alone. The inflammation spiral, month 6 through year 1. Here is where the story goes, somewhere most retirement health conversations stop short of reaching. Around the 6-month mark, two processes converge in a way the brain struggles to recover from without active intervention. The first is a drop in physical movement. This is counterintuitive because many people cite more time for physical activity as a reason for looking forward to retirement. But longitudinal data from the American Time Use Survey and multiple European cohort studies consistently show that retirement is associated with increased sedentary time, often by 1 to 3 hours per day, for the majority of retirees. The structured, mandatory movement that work embedded invisibly into daily life, commuting, walking between meetings, the physical arousal of being in an active social environment, even standing for extended periods, disappears. And in the absence of a deliberate replacement structure, it is not replaced. This matters for the brain in a very specific biochemical way. Physical movement is the primary driver of BDNF production. Brain-derived neurotrophic factor is a protein synthesized in neurons during and after aerobic exercise, and it functions in the plainest language possible as fertilizer for brain cells. It promotes the formation of new synaptic connections. It protects existing neurons from apoptosis, which is the process of programmed cell death, and it is the single most potent natural stimulant of neurogenesis in the hippocampus, the creation of brand new neurons in the one region of the adult brain where new neurons can actually be produced throughout life. Without regular aerobic exercise at a meaningful intensity, BDNF production drops, and a hippocampus that is already under circadian stress, already experiencing reduced cognitive load, and already losing synaptic connections to pruning, is now also losing its primary source of cellular maintenance and growth. The second convergence at the 6-month mark is inflammatory. Changes in meal timing, sleep architecture, social contact frequency, and perceived purpose, all of which tend to degrade in the absence of deliberate structure during the first year of retirement, are each independently associated with rising levels of chronic low-grade systemic inflammation. Specific inflammatory signaling proteins, including interleukin-6 and tumor necrosis factor alpha, cross the blood-brain barrier at chronically elevated concentrations and directly impair hippocampal neuron function. They disrupt the electrochemical communication between neurons. They introduce what is effectively static into the grid, and because this inflammation does not produce obvious symptoms, it does not hurt, it does not swell, it does not flag on a standard annual blood panel unless your doctor is specifically looking for it. It proceeds silently, degrading neural transmission efficiency across months and years. 3 mechanisms: synaptic pruning from cognitive unloading, BDNF reduction from physical deconditioning, and neuroinflammation from structural life disruption, are all compounding at the same time in the same brain region with no visible warning signals. The Whitehall 2 cohort study, which has followed tens of thousands of British civil servants across multiple decades, found that adults who retired before the age of 65 showed significantly faster rates of memory decline in the years following retirement compared to age-matched adults who remained in some form of cognitively demanding activity, even after controlling for baseline health status. The association held across socioeconomic groups, across health conditions, and across different occupational types. The age at which you exit cognitive load matters, and the trajectory after exit matters more. Here is what this means for you specifically. None of these mechanisms are irreversible. Every one of them, the synaptic pruning, the BDNF decline, the hippocampal shrinkage, the inflammatory cascade, responds to behavioral input. The grid does not just go dark and stay dark, it responds to electricity. The question is, what kind of electricity, at what dose, delivered through which channels? That is exactly what the triple load protocol addresses. But before I get to the protocol, something my husband put together is genuinely relevant here, and I would be leaving out something useful if I did not mention it. I had read all of this research. I had dug through the papers, understood the mechanisms, bookmarked the studies, and then I would wake up, make breakfast, sit with coffee, and drift into the exact low-load morning that the research says accelerates everything I was concerned about. The knowledge was not the problem. The absence of a daily structure was. My husband, who after his own health crisis about 8 years ago became relentlessly systematic about turning research into something you can actually follow on a Tuesday, had spent months building something he called the Noon Reset Protocol. He originally designed it as a 30-day companion for the intermittent fasting practice he had worked out for himself, but it expanded as he kept reading into something more complete. It is 2 pages per day. One page that walks through what is actually happening in your body and brain during that specific phase of the protocol, and one page that is a daily tracker for the variables that actually matter. The structure moves across 4 phases: adaptation, activation, optimization, and acceleration, which correspond to how the biology actually shifts over the first 30 days. The acceleration phase includes what he calls the Fat Walk Protocol, which is a specific timing and intensity approach to physical movement that the research on BDNF production and circadian anchoring directly supports. It also has 25 breakfast meal ideas with exact protein counts, because the first meal after the fasting window is where most people either reinforce the metabolic work they just did or inadvertently undo it. The whole thing takes under 5 minutes a day to follow. It is in the description below for less than a restaurant meal. I spent an embarrassingly long time not using the thing that was sitting right there on his desk. That part is genuinely funny to me now. If you are anywhere in the 6-month to 2-year window of retirement, or approaching it, this is the exact window where having that kind of daily anchor structure starts making a measurable difference. But now let me tell you what happens after year 1, because this is where the conversation goes somewhere that almost no mainstream retirement health content covers. The hippocampus withdraws. Year 1 through year 3, Dr. Kirk Erickson at the University of Pittsburgh published what may be one of the most practically important neuroscience findings of the last 2 decades in the Proceedings of the National Academy of Sciences in 2011. He took 120 adults aged 55 to 80 and randomly assigned half to a structured aerobic exercise program, walking around a track, building progressively to 40 minutes per session, 3 times per week, and the other half to a stretching-only control group. After 1 year, MRI scans showed that the aerobic exercise group had increased hippocampal volume by approximately 2%. The stretching group had lost 1.4% of hippocampal volume over the same period. That is a swing of 3.4 percentage points in the size of your primary memory organ, achieved in 12 months through walking at the right intensity. To give that number context, hippocampal volume loss is one of the earliest, most consistent, and most predictive neurological changes associated with Alzheimer's disease. The exercise group did not slow the loss, they reversed it. They grew the structure, and the mechanism was confirmed in the study through blood samples. BDNF levels rose significantly in the aerobic group and were directly correlated with the volume changes on MRI. Now consider what is happening to the average retired adult who has drifted into low physical activity over 1 to 3 years. Their hippocampus is not holding steady, it is losing volume year over year at a rate that the absence of BDNF cannot counteract. And the hippocampus is not solely a memory organ, it is the brain's primary spatial navigation structure, the region that allows you to build and update mental maps of environments. It is a key node in the emotional regulation network, involved in contextualizing emotional experience and modulating the fear response. When it shrinks, you do not simply remember less, you navigate physical space less accurately. You regulate emotional responses less efficiently. You process context with less precision. Processing speed, the rate at which the brain receives information and generates a coherent response, begins declining measurably faster in long-term retirees who have not maintained cognitive and physical load, compared to age-matched individuals who remain cognitively engaged, whether through continued part-time work, structured volunteer roles, creative practice with external accountability, or demanding learning. The Maastricht Aging Study, conducted over decades in the Netherlands, found that cognitive processing speed in individuals with low mental workload declined at roughly twice the rate of those with consistently high mental workload, even after controlling for age, education level, and cardiovascular health status. Twice the rate. Not because those people were unhealthy, not because they were genetically predisposed, because the grid had significantly less traffic. And the grid without traffic narrows. The social architecture collapses, year 3 and beyond. There is a final dimension of the retirement brain story that receives almost no airtime in mainstream health content because it requires saying something that feels uncomfortable but is strongly supported by the data. Most people's social infrastructure is far more intertwined with their professional life than they realize until that professional life ends. Work provides what sociologists call forced social contact. Not always meaningful, not always enjoyable, but regular, repeated, face-to-face interaction with people outside the immediate family and chosen social circle. And this type of contact is neurologically distinct from the interaction you get in comfortable, familiar relationships. Professional social interaction requires the continuous management of unfamiliar perspectives, the navigation of status relationships, collaborative problem solving under time pressure, and rapid context switching between different social registers. All of these are cognitively demanding processes, and they happen invisibly, embedded inside the mundane experience of going to work and interacting with colleagues. When that structure disappears, many retirees discover that their social contact drops significantly, even if they had anticipated the opposite. Work colleagues are not typically friends in the deep, durable sense. The relationship is contextual. When the shared context dissolves, the relationship usually dissolves with it, quietly, without conflict, simply through irrelevance. Researchers studying post-retirement social networks have characterized this as structural social loss, not rejection, not dramatic loneliness, but a gradual evaporation of the relational scaffolding that work was providing without anyone noticing. The neuroscience of social isolation is precise and unambiguous. Regular social contact stimulates oxytocin release, activates the prefrontal cortex and the temporoparietal junction, the region involved in modeling other people's mental states and perspectives, and reduces systemic inflammatory markers. Chronic social isolation, conversely, is now formally classified by the National Institute on Aging as an independent risk factor for cognitive decline and dementia, with research consistently showing that chronically isolated adults carry roughly 50% greater risk of developing dementia compared to socially connected adults after controlling for other health factors. 50% greater risk from isolation alone. That is not a secondary or marginal finding, that is a primary mechanism. Dr. Patricia Boyle at Rush University Medical Center conducted longitudinal research showing that higher purpose in life, a sense of direction, intention, and felt meaning that extends beyond daily pleasures, was associated with a 52% lower risk of developing Alzheimer's disease and a significantly reduced rate of mild cognitive impairment, even after controlling for cardiovascular health, depression, and prior cognitive status. Purpose is not soft psychology here. It is a measurable neuroprotective factor with detectable effects on brain pathology at autopsy. And purpose, for many people, was something their professional role was delivering every single day without them having to construct it deliberately. Here is the part that reframes everything. Within all of this mechanism, there is a consistent group of retirees who do not follow this decline trajectory. Not because they are wealthier, not because they have better genetics, not because they found the right supplement. Multiple longitudinal studies separating retirees by cognitive outcome consistently identify the same three behavioral variables as distinguishing the stable group from the declining group. Not one variable, three, and they tend to co-occur. When all three are present, the cognitive aging trajectory looks dramatically different. When any one is absent, the protection degrades. This pattern is consistent enough across different populations and different countries that it has become the empirical basis for what researchers describe as the cognitive reserve maintenance model of post-retirement life. The three variables are cognitive load, social load, and physical load. Every day, together, this is the triple load protocol. Component 1, cognitive load replacement. This is not reading for pleasure. It is not watching documentaries, even excellent ones. It is not casual language learning on a phone app. The brain requires genuine challenge, problems with stakes, where the answer is not known in advance, where working memory is stretched past its comfortable capacity, where social judgment is engaged, where error is possible and informative. Research on effective cognitive load for brain reserve suggests a meaningful minimum of 45 minutes of genuine cognitive challenge per day. Practical targets that the research supports: learning a musical instrument with a teacher who corrects your errors, taking a course with graded assignments and external evaluation, writing with the intention of being read and critiqued, facilitating a group of people with real responsibilities, building or engineering something physical that requires ongoing problem solving across multiple sessions. The critical criterion is difficulty. The activity must be hard enough that you make meaningful mistakes. This matters because the brain's neuroplasticity response is triggered by the error signal, the moment when the expected outcome did not match the actual outcome. That mismatch is what prompts the brain to strengthen and reorganize circuits. No genuine difficulty means no meaningful error signal. No error signal means no adaptive neuroplasticity. Comfortable cognitive activity, regardless of its intellectual content, does not build reserve. Component 2, social architecture. This is not coffee with your neighbor twice a week, though that is not without value. Research-grade social protection for the aging brain requires what sociologists call bridging contacts, interactions with people outside your existing close network who bring genuinely different perspectives and require you to navigate unfamiliar social contexts in real time. The minimum effective dose, based on longitudinal studies of retirees with stable cognitive trajectories, appears to be 3 structured social interactions per week that involve collaborative problem solving or perspective taking under some degree of social accountability. Specifically, activities where you are responsible to other people, where something consequential is at stake, and where you are expected to contribute, not simply receive. Volunteer work in an advisory or leadership role, joining a group with a shared goal and a deadline, mentoring or teaching in a structured setting, participating in a team project where your presence or absence matters. The key distinction is between passive social presence and active social participation. Attending a group lecture is not neurologically equivalent to being expected to contribute to the discussion. Sitting in a social environment is not the same as being cognitively engaged within it. The brain benefits from social contact where it is actively working, not spectating. Component 3, physical load at BDNF threshold. The type of physical activity matters specifically, and the specificity here is worth taking seriously because most retirement health advice on this point is too vague to be actionable. The research on BDNF production, the Erickson study, and the numerous replications and extensions that followed it across the last 15 years consistently shows that the relevant trigger is sustained aerobic exercise at moderate to vigorous intensity for a minimum of 20 to 30 continuous minutes, at least 4 times per week. The practical test for whether you are in the productive zone is simple. During the activity, you should be able to speak in short sentences, but not comfortably. If you can carry on a full conversation without any effort, you are below the intensity threshold. If you cannot produce words at all, you are above it, and you are likely working in a zone that produces stress hormone responses that partially counteract the neuroprotective benefit. The productive window is what exercise physiologists call Zone 2, the uncomfortable but functional zone, where your cardiovascular system is genuinely loaded but not overwhelmed. Walking counts, but only brisk walking on varied terrain for most people over 60, not a leisurely flat ground stroll. The intensity is the mechanism, not the activity itself. The single most common mistake that invalidates all three components simultaneously is treating them as separate, isolated activities that happen in their own time blocks. The research suggests that the most potent neuroprotective effects come from activities that combine at least two of the three loads at the same time. A brisk walk with a genuinely challenging conversation, not catching up, but actually working through a problem together, is measurably more beneficial for hippocampal health than either activity alone. A group physical activity that also involves coordination, strategy, and real social stakes is more effective than solo exercise, plus a separate social event. A learning environment that involves movement and interpersonal challenge simultaneously hits the brain with the combination of signals it is most responsive to. This is not arbitrary. The brain evolved under conditions where physical movement, social coordination, and environmental problem solving happen concurrently as the basic structure of daily life. You were never designed to exercise alone on a machine while watching television, then do a cognitive activity in a chair, then make a phone call. You were designed to move through an uncertain environment with a group of people who depended on your judgment, navigating real problems together with real consequences. The triple load protocol is not a hack. It is an attempt to reconstruct the input conditions under which the human brain was built to maintain itself. And the research on retirees who do not cognitively decline strongly suggests that the people who find a way to replicate those conditions, even in radically different modern forms, are the ones whose power grids stay lit. If you are starting the triple load protocol this week, comment TLP below. I want to see who is actually doing something with this, not just filing it away with every other health video that gets watched and forgotten. And subscribe, because next week we are going into the specific nutritional inputs that either amplify or undermine every single one of the mechanisms we covered today, and one of the numbers is going to genuinely surprise you.